All right, guys, welcome to lesson 11, a power to an exponent. So our learning goals today is I am learning to raise a power to an exponent, and I'm learning to raise a product to an exponent piece by piece. And you'll see what this means in a minute. It says watch the video. Because I'm filming this lesson, we're not going to watch the video. But it says, what is the rule for raising a power to an exponent? Okay. So remember, a power is something like 5 squared, okay? This whole thing is a power. And if we raise this whole thing to an exponent, let's say the exponent's 3. Okay. What we do here is we actually multiply the exponents. Okay, and that will be our new exponent on the number. So we do 2 times 3, which would be 6. So 5 to the power of 6. And the reason it works like this, guys, is think about what 5 squared means, right? 5 squared means 5 times 5. Okay. And then if we have 3 of those, then we have 5 times 5 times 5 times 5 times 5 times 5. Okay. So we have 5 squared. This is 5 squared, right? 5 times 5. And we're doing 3 of them. So 1, 2, 3, which gives us 1, 2, 3, 4, 5, 6. 6 5s being multiplied. So that's why it makes sense that we have 5 to the power of 6. Okay, because there's 6 5s being multiplied. But basically what the rule is here is that you just multiply these two numbers, right? So when we get going, we won't write this out every time. We'll just do the rule, which is we multiply exponents. So if you want to write that as a note, we multiply exponents. Okay. So our first example, we're applying this new exponent rule we just learned, and we are simplifying, and then we are evaluating. Okay. So remember, simplifying means to do the exponent rule. So this is going to equal, the base stays the same, so it stays as 3. And then we do 2 times 4, because this is an exponent on top of another exponent. Okay. So 2 times 4 is 8. So we have 3 to the power of 8. And now we evaluate, which means we plug it into our calculator. It's very important we show both steps, because I'm not testing your ability to plug it into a calculator. I want you to make sure you know this exponent rule, okay? So this is 6,561. Okay, and that would be our final answer. So again, this is simplifying, this is evaluating. Okay. Next one, base stays the same, 2, and then we do, this is an exponent on top of another exponent, so we do 5 times 2, which is 10. In our calculator, 2 exponent 10 is 1,024. So when we evaluate this, we get 1,024. Okay. Next one. We have -5 in brackets with a 3 and an exponent on top of all of that. So if we do this, so we have -5 as our base. That stays -5. And then we multiply the exponent. So 3 times 3 is 9. Okay. So this is simplifying, and then evaluating. You should put this in brackets. Okay. So bracket, -5, close the bracket to the exponent of 9. So when we evaluate this, we get a big number. We get -1,953,125. Okay. Okay. And last one before we get do some that are a bit different. Again, base stays the same, so we have 10, and then we multiply exponents. 3 times 2 is 6. 10 to the power of 6, this is just going to be 1 with a bunch of zeros, right? 10 to the power of 6. We have 1 million, right? So we have 6 zeros. Okay, so when we evaluate this, we just have 1 million. Okay. 1 million. All right, next example. These ones are pretty quick and easy. When we have just a variable, we can't evaluate because there's no number to evaluate, right? So base stays the same, so it's just gonna be x, and then we multiply 4 and 5. So x to the 20. Next one, base is y. Multiply exponents, 3 times 4 is 12. Okay, again, remember, pause this if I'm going too fast, but all we're doing here is keeping the base the same, multiplying exponents. So next one is k, 6 times 2 is 12. Okay, next one is m, 7 times 3 is 21. And last one is x, 2 times 7 is 14. Okay, and that's it for those ones. So as we go here, we'll get a little bit more complicated, okay? This is combining the exponent rules we learned the last couple days with this new one we just learned, okay? So when we're doing a question like this, you want to deal with the exponents on top of another exponent first. So you see you have them here. You also have them down here. So we're going to deal with those first. So this first one, the base stays the same. And then we do 8 times 7, which is 56. Okay, so 2 to the power of 56, 2 exponent 56. Multiplying 2 to the exponent of 19, 2 exponent 19. Then we're dividing all that by, again, the base is 2, and then we do 9 times 8. 9 times 8 is 72. Okay. So that is simplifying it to get the exponents simplified. Now we need to combine these things, okay? Remember, when we're multiplying powers, we add exponents. So we're adding these two exponents here, okay? Because we're multiplying the two powers. So we have 56 plus 19. 56 plus 19 is 75. And this is being divided by 2 to the exponent of 72. Okay. Next line, so we have a fraction here. We're dividing. When we divide two powers, remember we subtract exponents. So we're subtracting these exponents. We have, sorry, this is not a z, this is a 2. I don't know why I wrote a z. 2. 75 minus 72 is 3. Okay. And then we are evaluating this one as well. So if we evaluate this, 2 to the exponent of 3 is going to be 8. Okay. Awesome. On to the next one. Okay. So again, deal with the exponent, the power with the exponent on top first, which remember we just multiply here. So we're going to leave it. The base is 3. Then we do 11 times 4, which is 44. This is being divided by, we want to multiply these powers. So base is the same. It stays as 3. We multiply 8 and 5 to get 40. And then we're subtracting 3 to the exponent of 3. Okay. So next step, we're dividing powers here, which means we subtract exponents. So base stays the same, it stays 3. 44 minus 40 is 4. And then we're subtracting 3 to the exponent of 3. Okay. If you do that, so we're subtracting exponents here. There's no rule for this, right? you cannot add these exponents, you cannot subtract these exponents because we're not multiplying or dividing, we're subtracting, okay? So if there's no rule, you need to evaluate both of these and then subtract after, okay? So 3 to the power 4, let's do that in our calculator. 3 exponent 4, we get 81. So we have 81 minus 3 exponent 3. 3 exponent 3 is 27. Okay, so our answer is going to be 81 minus 27. 81 minus 27, which is 54. Okay, very important that you don't make this mistake, right? Don't add or subtract or multiply these exponents. You have to, there's no rule for this, so you have to do them individually, subtract them after. Okay? Last example on this page. Again, as we've been doing, you're going to get rid of the power with an exponent on top first. And this one just has x's, so there's no evaluating here, right? So we have x, 15 times 3 is 45. We're multiplying that by x to the 26, and dividing that by x. Here we do 10 times 5, which is 50. Okay. 45 plus 26, right? Because we're multiplying exponents, we add. We're multiplying powers, so we add exponents. So we have x, 45 plus 26, 71. So x to the 71 over x to the 50. Okay, when you're dividing powers, you subtract exponents. So 71 minus 50 is 21. So our final answer is x to the 21. X to the exponent of 21. Okay. So now we can move on to the back side. Remember, pause this video, go back if you need to, if I'm going too quickly. And let's see what we have on the back. So our first question here is, what happens when we raise a product to a power? Okay. So if we think about this one, okay, we have 5 times a to the exponent of 4. So this is our product because they're multiplying. And then we're raising that to another power. Okay. So what this means, if you were to write this out, right, we have 3 of these being multiplied. So we have 5a to the 4 times 5a to the 4 times 5a to the 4. Right? We have 3, exponent is 3 of these being multiplied. And if you were to do this, you do 5 times 5 times 5, which is actually the same as 5 to the power of 3, right? So if you multiply 5 by itself 3 times, it's 5 to the power of 3. And then we have a. If we're multiplying exponents, multiplying powers, we add exponents, right? So 4 plus 4 plus 4 is 12. Okay. So then we can actually evaluate this 5 to the power of 3. 5 to the power of 3, 5 exponent 3 is 125. So we have 125 times a to the 12. That would be our answer. So basically all we did here, so this is drawing it out a little bit, but what we did here is we took this 3 and we applied it to the 5. We also applied to the 4, right? So 5 to the power of 3 is here. And then this is an exponent on top of another exponent, so we need to multiply. 4 times 3 is 12, so that's where that 12 came from. And then we just evaluate the one with the number to get 125a to the exponent of 12. Okay, so let's do a few more examples like this. Okay, again, this 4 applies to the number out front as well as this exponent. So we are going to have 3 exponent 4. And we are also going to have, so here our base is x, and then 2 times 4 is 8. And then we can evaluate this first part, 3 to the power of 4. 3 exponent 4 is 81. So we have 81x to the 8. Okay. So that's that one. Next one, these are all going to be very similar. We're applying the 5 to the 2, and we're multiplying it by the 3. So it's 2 to the power of 5, and x, 3 times 5 is 15. And then we just have to do this 2 to the power of 5 in the calculator. 2 exponent 5 equals 32. So it's 32, and then this is still x 15 is our final answer. Okay. Keeping this going. This 2 is going to apply to both. So we have 5 squared, and we also have b. And then remember multiplying exponents, so 3 times 2 is 6. 5 squared is 25. And then b to the 6 just stays as b to the 6. And that is our final answer there. Okay, next one. Now we have 3 terms, but nothing changes here. We just apply this to all 3 terms, okay? So 2 to the exponent of 4, we can write. And then 4, this is an exponent on top of this power, so we multiply exponents. So 5 times 4 is 20. So we have x, 20. And then we have y, 3 times 4 is 12, so y to the 12. And then we do 2 to the power of 4, or 2 exponent 4, which is 16. So we have 16, x 20, y 12 as our final answer. Okay. Okay. Let's see what Marcy and Lenny are up to in this question. So Marcy and Lenny each tried to simplify the expression 3a squared b to the 4 all to an exponent of 5. So it says Marcy's solution is here, Lenny's solution is here. Are either of the students' solutions correct? If so, which one? Okay, so let's take a look here. So if we applied this 5 to the 3, we would have 3 to the 5, so that's good. Here we'd have to multiply 2 and 5. 2 times 5 is 10, so that's good. And here we multiply 4 and 5. 4 times 5 is 20. So this does seem like the right answer here. Let's take a look at what Lenny did. Okay, right away you can see. Okay, and this actually printed wrong, sorry. This was supposed to be part of Marcy's solution. Okay, because if you do 3 to the exponent of 5, you'll get 243, and this is actually going to be the right answer. Okay, so ignore that, just printed wrong. Okay, so here, the 5 needs to apply to the 3. So that's why this is wrong. This is not right because Lenny didn't apply the 5 to this first 3 here. Okay? So we can say Marcy's solution is correct. Lenny forgot to apply the exponent to the 3. Okay. Marcy's solution is correct. Lenny forgot to apply the exponent to the 3. He forgot to put this exponent of 5 on top of the 3. Okay. Okay, final couple examples here. So we have power of a quotient. Quotient, remember, means to divide. And it says, think about how to simplify this one. Okay. These bases, x and y, are different, so we can't combine those. But all we can do is apply this 4 to both. So that's the important thing here, is if you have a fraction like this, you always just apply this 4 to both, and we multiply, right? So let's look at this example. So we are multiplying exponents, so this is going to stay a fraction. So x is on top. We do 2 times 3, which is 6, over y, and then 10 times 3, which is 30. Because these are variables, x and y, there's nothing else we can do, and that's our final answer. And they're different, so we can't combine them, right? The bases are different, so we can't combine them. Okay, next one. A to the 5, exponent 3, so it stays a. And then we have 5 times 3 is 15. Okay, and that's all over. And then this 3 has to also apply to the b. Okay, so we have b to the exponent of 3. And I wrote another equal sign, but there's nothing we can do because, again, the bases are different, so we cannot combine them, and this is our final answer. Okay, and these are similar, but now these two are the same variable, the same base, right? So we can start by doing what's in the brackets. So we have m8 divided by m6. If you're dividing two powers, you subtract exponents. So this stays as m. Then you do 8 minus 6, which is 2. This is still to the power of 4. And now we have a simple question that we started with, right? So like we did on the first page. So we multiply these two exponents and we get m to the power of 8, right? 2 times 4 is 8. That's our final answer. Okay. Same thing here. Our bases are the same, top and bottom. So we can keep the base the same and then do 6 minus 2, which is 4. And that is all to the exponent of 3. Base stays the same. We multiply exponents. 4 times 3 is 12. 7 would be if you're adding them, but we're multiplying. So x to the 12 is our final answer. Okay, so now you guys can go ahead and work on the practice. We will have a test coming up on Wednesday this week. So please complete the practice, ask questions if you have them, and check your solutions on the last page there. Okay, good luck, guys.